Hello, David Kenworthy here again. The date is the 7th of the 6th, 2021. It's nearly 1:30, and we're going to talk about Plimpton 322, the Rosetta Stone of ancient metrology. Now, Plimpton 322 is the best evidence we've got, and Wildberger and Mansfield have done a lot of work around it, and it's all on the internet, and it's fabulous stuff. Here's some examples of what they've done. They're talking about the complexity of this tablet, and they're telling us here how the tablet is broken down and what the numbers are in the tablet. And it just goes on and on and on, this analysis. It's just absolutely incredible. I don't need to say anything about it, except that I'm going to agree everything that they're telling us about this tablet, about its properties and its qualities, and about the people that designed it. But I'm also going to be able to corroborate their findings on line 1 of this tablet with a lot of the findings of other investigators. And this is what we're going to do. We're going to look at Thom's megalithic yard, because we can corroborate that value using line 1. And Berriman's Egyptian digit, which is the Egyptian metre of 39.375 inches divided by 54. And it's that number of inches. We've got Crowhurst's values that he's found at Carnac in France. The Pythagorean triangle 119, 120 and 169. Now, Crowhurst got very excited when he saw this Plimpton 322 presentation by the professors, because he knew this value. He knew he'd found this value, and he knew what the professors were talking about, these Babylonian values, were what he was finding at Carnac in France. And we're going to look at this line 1 that Wildberger and Mansfield have re-analysed for us. And they produce this number on line 1, which is this here. It's 119 divided by 120, and it's 0.99166667. And that's what we're going to use to produce all this analysis. Now, I want to go to my book that I've co-written with Hugh Franklin, called From Stonehenge to Giza. And this is an extract from it, and it's called the Rod's Reconciliation. And Rod's is a Polish Old Testament researcher who's discovered this value of 364.58333 recurring days being used in the Old Testament. And we can produce this value by using Berriman's Egyptian digit, because there are 50,000 Berriman Egyptian digits in this value, 36458.333, and that's the value that we're now going to pull out of Plimpton using Thom's megalithic yard. So we've got this value, we divide it by 2.72, we get this value here, 364583333, we multiply it by 2. It's not working, because it is working, and there we are, 0.729166. It's this value, 39.375 inches divided by 54 digits. Now, I want to show you where this is in Berriman's book, because it's very important that we get it right about what he's telling us about the meter. And there's some really great stuff in this book by Berriman. And the little paragraph is called The Inch and the Metre, and it's on page 21. I'll try and get this in focus. Yeah, we can see that, the inch and the metre. The name digit is assigned here to the sexagesimal fraction of the terrestrial circle that measures 1/54 metre. And that's it. 54 digits in a metre. So we know the length of the digit It's 39.375 divided by 54. It's that. And when we divide that by 2, we get this, which is this Bogomelia Chrysiac Old Testament value of 3645833 days. And in the book, From Stonehenge to Giza, that's the value that I've used in my reconciliation. So let's go back to it again. It's here. It's there. 3645833. Now, I'm not saying that is the is the full value. I'm saying that is a stepping stone to the full value that we're using at Giza, and that's this value here, 3666.6667. And the difference between these two values is this, 2.08333 days. And we can get this value at Stonehenge because Thom's using 6.8 as his megalithic rod and 32.64 as his megalithic yard. Now that's in feet and that's in inches, but it doesn't matter. It's the numbers that are important, not the units. So if you divide that by that, we get that. We can also do it in what I call the eclipse system, where that 66 feet is the imperial chain. And we're going to divide it by this number, which, according to John Michel, is one of the roots of ancient metrology, 31.68 inches. We divide that by that and we get 2.08333. That's the number of days found at Stonehenge that is this stepping stone. And what is this stepping stone between these two values, 36666 and 36548.3? It's this number here, which is 1760 divided by 1750. And when we actually divide these two values by these two numbers, we get what I call the golden cubit. There it is, the golden cubit. It's base 100, and all of the cubits are derived from this value. And the Stonehenge cubit in feet is this, and the golden cubit used at Giza is this. So if we go back to the book that Hugh and I wrote, we'll see where it is. And we've got this Berriman digit here, and we've got this value here that we multiply by 176 divided by 175 to get this. So we also have to change the digit, and we do the same adjustment, and we get 0.7333 as the base 100 digit. And this little table, this Rod's reconciliation, as I've called it, underlies all these calculations, and we're finding it in line 1 of Plimpton. So let's go back and see if we can find some evidence to support what I'm saying about Crowhurst. Where did he comment on this? I think it might be here. Just stop that. No. Let's go back. There it is, Howard Crowhurst. I nearly cried watching this. This is the exact way of thinking of the megalithic builders in Carnac, France from 5000 BC onwards. I've shown in my books, mostly available only in French, how the 119-120-169 triangle was used at the Manio site in Carnac. Its larger angle is exactly the double of the 5-12-13 triangle. To pass from one to the other, use the following method. And he gives his method. Now that is something, that is, isn't it? And what I've done I've added 5 days ago. Hello, Howard. The 119, triangle can be linked to the work of Elgin and Berriman in his book Historical Metrology, published in 1953. This works using Thom's megalithic yard. I'm currently working on a video presentation to show exactly how this happens, and we'll link it here when it's completed. So what I'm going to do is link this video to there when I've finished going on about it. So I think I'll stop there. There's a lot more to talk about here, but I'm going to stop there because otherwise the video will get too long.